In this video, we're going to look at these animals called piecewise functions. And piecewise functions are a little bit different than the functions that we've been looking at because a piecewise function is defined differently at different components of its domain. And so a piecewise function might be linear at some points, it might be quadratic at others, it might be cubic in others. It just depends upon how the piecewise function is constructed. And so what we're going to do is we're just going to take a look at how do we graph piecewise functions, how do we evaluate values, and how do we describe some of the components of it. So this is what a piecewise function looks like in general. So notice that we say that the function is defined as x plus 1 whenever x is greater than 1, and negative x squared whenever x is less than 1. And so what we do is, to evaluate a piecewise function, we just select which of the conditions is satisfied by the input. So if I wanted to evaluate f at 2, well, clearly f at 2 would fall in this expression because 2 is greater than 1. So f at 2 would be 2 plus 1, which is 3. And then if I wanted to go through and evaluate f at negative 1, then notice that negative 1 falls in here because negative 1 is indeed less than 1. And so that would be the opposite of negative 1 squared, which just turns into negative 1 once we evaluate. Now, just like any other function, not every value is going to be given inside the domain. So f at 1, notice that if we go through and we take a look at that, well, 1 is neither greater than 1 nor less than 1, right? So f at 1, we would say, is undefined for this function, okay? Or it does not exist just because it's not within the domain. Now, next thing we want to do is we want to graph this function, all right? So what we're going to do is we're going to make two tables of values. We're going to make one table when x is bigger than 1, and we're going to make one table when x is less than 1. We're going to graph. So for x plus 1, right? So this is going to be our x and our x plus 1. Now, I know that 1 is not in the domain, but I'm going to start with 1 and maybe do like 1, 2, 3, and 4 just to get an idea of what this looks like. And of course, if we just add 1 each time, that's going to be 2, 3, 4, and 5. And again, these are ordered pairs, right? So don't forget the whole purpose of the table is to create an ordered pair. But remember, this is not in the domain. Okay, so what's going to happen is we're going to put an open circle at that point once we construct the graph. Right? Now, we're going to do the exact same thing with negative x squared. Okay, so we have our x and we have our negative x squared. And remember, we're saying that x is going to be less than 1. All right, so let's start at 1 once again. So 1, 0, negative 1, negative 2. And when we substitute values, this is going to be the opposite of 1 squared, which is negative 1, opposite of 0 squared, which is going to be 0. And then we have the opposite of negative 1 squared, which is going to be negative 1. And then finally, the opposite of negative 2 squared, which is going to be negative 4. And again, these are ordered pairs. So the ordered pairs we get are 1, negative 1, 0, 0. And we get a negative 1, negative 1. And finally, we get a negative 2, 4. But again, this point, 1, negative 1, is not in the domain of the function. And again, we're going to put an open circle there. Okay, so not in our domain. And so we put an open circle in the graph. And now we're just going to plot the points, and we're going to graph these separately. Right? So here's our Cartesian plane. And we have 1, 2. And remember, we put an open circle there. And then we have 2, 3. So we have a point here, about. And we have 3, 4. And then finally, we have 4, 5. Right? And it looks like it's just going to follow this linear pattern. All right. And I probably would have looked a lot better had I not drawn on a computer screen, but that's what we get out of it. Now, we're going to graph the other part of the function. So we have 1, negative 1. And remember, that's an open circle there. And then we have 0, 0. This is right here. And then we have -1, -1, and then we have -2, -4. All right, so it looks like we get this sort of shape. All right, and remember, again, this is an open circle, so that means that right here with the open circle, it's not part of the domain. All right, so the last part of this is to identify what the range of the function is by using the graph. And notice that there's a hole right here. Okay, so right here, this would go up to 2, and we have a 0. All right, so there's a break basically between 2 and 0 with the range of this graph. So if I was to describe the range of this graph, we would say that y is an element. Now notice it keeps going down forever. All right, so it's going to go from -infinity. It's going to keep going up. Okay, so we increase, we increase, we increase, we increase until we get to the 0 right here. Okay, so we're going to go to 0, and it is going to include the 0. Okay, so that means that we're going to put a hard bracket. Um, and even though this point is not in the domain of the function, all of the values, remember the range is all the y values, all of these values are indeed. So this point right here suggests that 1 is in the range of the function. Now we're going to union this. We start up again at 2, but there's an open circle. So it's going to be parenthesis 2, and that's just going to keep going forever till infinity. All right, so that's going to be your range of the function for this. A secondary example, and this might be one where you just want to practice this and pause the video just to make sure that you understand how to plot piecewise functions. Once again, what we're going to do is we're going to plot these, or we're going to go through and evaluate. So f at 2, we know that 2 is going to be less than 3. All right, so it's going to be 2 times 2, which is 4. And then we need f at -1. And that's going to fit this condition. I'm sorry, that's also going to fit the first condition, excuse me. So that's going to fit this condition as well, since that's less than 2, or less than 3, excuse me. So we have 2 times -1, which is -2. And then finally, we find f at 3, and we notice when it's exactly 3, the output is going to be 7. All right, so those are going to be our 3 components for this. Now, just like we did before, what we're going to do is we're going to make some table of values for this. All right, and we're only going to make the table of values for the first 2 because this is just going to be an ordered pair. All right, so this just means that the point 3, 7 is going to be on the graph somewhere as a point. Okay, but for the other 2, let's make a table of values. So we have x, and then we have 2x whenever x is less than 3. And we are going to start at 3. Okay, so maybe 3, 2, 1, 0. And remember, this is an open point. So we just take 2 times 3, which is 6, 2 times 2, 4, 2 times 1, 2, 0. These are ordered pairs, right? So it might be helpful for you to remember them as this. All right, and remember, this is not in the domain. Okay, so we'll put an open circle there. We're going to do the same thing with 4 minus x. So we have our x, and then we have our 4 minus x, and that's for when x is greater than 3, right? So we're going to start at 3, so maybe 3, 4, 5, and 6. And then if we just subtract the number x each time, 4 minus 3 is 1, 4 minus 4 is 0, 4 minus 5 is -1, 4 minus 6 is going to be -2. And again, these are ordered pairs, but we notice that this is not in the domain. And we're just going to represent that by an open circle. And so if we plot this, not forgetting that the point 3, 7 is going to be on the graph somewhere. Excuse me. So we go ahead and plot. So we have 3, 6. And we remember that there's going to be an open circle there. Okay. Then we have 2, 4. All right, and then we have 1, 2, and then we have the origin 0, 0, and it looks like that we get this linear relationship for this part of the piecewise function. So it's just going to do one of these animals. And then for the other part of it, we have the point 3, 1. So we go 3, and there's going to be an open circle at the point 3, 1. Then we have 4, 0. And then we have 5, negative 1. So we get a point here. And then finally 6, negative 2. Right about there. And we get another linear relationship that looks like this. And of course, we can't forget that there's going to be the point 3, 7 somewhere in here. Okay, so right here, that's because f at 3 was equal to 7. All right, now, just like the previous, the last thing that we have to do is we have to identify what the range of this function is. All right, so this is part 2 where we graph it. Now, part 3, the range is pretty easy until we get right here. Okay, and so when we define what the range is for this, now notice that the function keeps going down forever. And even though this point is omitted right here, we know that 1 is within the range of the function because it's somewhere on this part of the linear function, like maybe right about here or whatever it is. So for our range, we would say y is an element negative infinity, and it's going to go all the way up here. Okay, and remember this is basically like one of the endpoints 6. Right? And then the other thing that we remember is that 7 is going to be on the graph. All right, so we're just going to have to union 7, 7. All right, so that's how we're going to have to go through and try to identify what the range of this function is going to be. In my math lab, they might just ask you or just tell you that there's a specific point in there. So you might just give this part of it in my math lab, and you can also say something to the effect of that y is equal to 7 is also a part of the domain as well, or the range, excuse me. Okay, so that's all for piecewise functions. Not too difficult, all right? Just basically being able to plot, make some table of values. The last thing that we're going to look at this section, unfortunately, is the most algebraically taxing. That's going to be the difference quotient. Okay, so we'll take a look at that, and that'll be it for this section.